Right, so here's another past examination question. So this is from Edexcel. It's a further maths question from FP3, June 2012, and this was question 7 on that paper. So let's have a read. F of x is given by 5 hyperbolic cos x minus 4 hyperbolic sin x, and in part A we need to show that f of x is half into e to the power x plus 9e to the minus x. So let me copy down f of x. So f of x, so that's defined as 5 hyperbolic cos x. So let me just be even clearer, minus 4 hyperbolic sin x. Now I'm going to be using the definition of hyperbolic cos and hyperbolic sine in order to write my answer in terms of exponentials. So if I pick up a red pen, so remember the definition of hyperbolic cos x. So in terms of exponentials, hyperbolic cos has the definition e to the x plus e to the minus x divided by 2. And there is also a definition for hyperbolic sine, so that has the definition e to the x minus e to the minus x divided by 2. So I'm going to be using both definitions here to write f of x in terms of exponential functions. So let me go back to blue. So f of x, that is equal to this 5. And let me replace the hyperbolic cos, which is e to the x plus e to the minus x, all divided by 2, minus the 4 from here. Hyperbolic sine, let's replace that by e to the x minus e to the minus x, all divided by 2. So if I take a common denominator of 2, so let me take a common denominator of 2. So in a numerator we'll have 5 into e to the x plus e to the minus x minus the 4 into e to the x minus e to the minus x. So this is what you should have upon taking a common denominator of 2. And if I continue further, if I multiply the brackets in the numerator, 5 into e to the x, so that is 5e to the x. 5 times e to the minus x is plus 5e to the minus x. Minus 4 times e to the x is minus 4. Whoops, so let me be as neat as I can. Minus 4e to the x. And minus 4 times minus e to the minus x is plus 4e to the minus x, all divided by the 2 below. And if I scroll down a little, let's simplify. So let me simplify by adding the like terms on the top. So I have a 5e to the x minus 4e to the x, so that is 1e to the x, or simply e to the x, and 5e to the minus x plus 4e to the minus x is plus 9e to the minus x, all divided by the 2 below. And as you can see, we're almost there. So what I'm going to do is I'm going to take a common factor of half. So if I take a common factor of half, I'm left with e to the x plus 9e to the minus x. So as you can see, this is exactly what that we need to show. So this should be the solution to part A. Now for part B. Part B is to solve f of x is equal to 5. So let me continue. Let me continue over here. So for part B, we need to solve f of x is equal to 5. So let me double check that I've copied down the correct thing. So let's have a look. So f of x, let me use this solution in terms of exponentials. So I'm going to copy that down. So I have half e to the x plus 9e to the minus x, and that is equal to 5. Let me multiply both sides by 2. So if I multiply both sides by 2, I'll get e to the x plus 9e to the minus x, and that is equal to 2 into 5 being 10. And I don't like negative powers, so I don't like this e to the minus x. Let me get rid of the negative e to the, let me get rid of that negative powered term by multiplying throughout by e to the plus x. So if I multiply this equation by e to the plus x, I'll have e to the x squared. So e to the x times e to the x is e to the x squared, plus 9e to the minus x times e to the plus x is simply 9, and that is equal to 10 times e to the x, that is 10e to the x. Now let me take the term on the right hand side and move it to the left to give me this quadratic in terms of exponential functions. So I have e to the x squared minus the 10 e to the x plus 9, and that is equal to 0 on the right. So let me continue from here. Now I'm going to use a substitution to help me with this one. So I'm going to let t equal e to the x, and if I let t equal e to the x, or if I simply replace e to the x by t, we're going to have t squared minus 10t, so I'm replacing the e to the x terms by t, plus the 9, and that is equal to 0. And further to that, it's possible to factorize this quadratic. So if I were to factorize, the factors would be t minus 1 and t minus 9. And using this factorized expression, let's find the t values. So one of them, so either t minus 1 is equal to 0, and if I take the minus 1 to the right hand side, that implies that the first t value is plus 1, or t minus 9 is equal to 0, and if I take the minus 9 to the right, I make the next value of t plus 9. So here are the two values of t, but we're looking for the values of x. So let's go back to the substitution here. So let me continue over here. So I'm going to say since t is equal to e to the x, let's firstly see what happens when t is equal to 1. So if I replace t by 1, so when t is 1, if I replace it in this substitution, e to the x is equal to 1, and if I take ln's on both sides, that would lead to this equation, x equals ln1, and ln1 is simply 0. So that is the first answer for x. Now let's see what happens for when t equals 9. So let's continue. So when t is equal to 9, so if I replace into this substitution, e to the x is equal to 9, and if I take ln's on both sides, x therefore is ln 9. So here are the two values of x equals 0 and x equals ln 9. These are the solutions for the equation fx equals 5. So that finishes off part B. Let's have a look at part C. So part C. Show that the integral between half ln3 and ln3 of 1 over 5 hyperbolic cos x minus 4 hyperbolic sin x with respect to x gives us an answer of pi over 18. So let me copy the left hand integral. So we're integrating between half ln3 and ln3. So they are the limits of this integral of 1 over, and in the denominator we have 5 hyperbolic cos x minus 4 hyperbolic sin x with respect to x. Now, if you observe, this term in the denominator is identical to f of x, and we wrote f of x as a summation of exponential functions. So we expressed f of x in terms of exponential functions. We wrote it as half e to the x plus 9 e to the minus x. So let me replace the term in the denominator by our answer in terms of exponential functions. So let's see what we're going to get as a result. So our integral, so if I scroll down a little, so our integral with limits half ln 3 for the lower limit and ln 3 for the upper limit, 1 over, and let me replace this term in the bottom by f of x in terms of exponential. So let me copy that. So we have half, so a half, open a bracket, and we have e to the x plus 9 e to the minus x. So e to the x plus 9 e to the minus x. So this is what we have below. And we're integrating with respect to x. Now let's tidy up this integral. So our integral with limits half ln 3 and ln 3. 1 divided by half, first of all, is 2. So I'll keep that 2 on top. Over the e to the x. So here's my e to the x term. Plus the 9. So plus the 9. E to the minus x. That is the same as 1 over e to the x. With respect to x. And let me take a common denominator of e to the x as far as these brackets are concerned. So our integral between half ln 3 and ln 3. So we have 2 on top. So let me retain that 2 on top. And if I take a common denominator, so I'm focusing on this bracket. So if I use a green pen, let's have our eyes on this bracket highlighted in green. Going back to my favourite colour, blue, of course. If I take a common denominator of e to the x, on the top we're going to have e to the x times e to the x, which is e to the 2x plus 9. So this is what we should have as a result of taking a common denominator of e to the x on the bottom as far as these green brackets are concerned. And if I go to my favourite colour, blue, now let's tidy this up, so let's not forget the dx. So if I tidy this up in the next step, so we're integrating between half ln 3 and ln 3. This e to the x, so 1 over e to the x, if we take the reciprocal, so that will give us 2e to the x, so the e to the x in other words will come on the top, divided by, so let me be as neat as I can, e to the 2x. Now I can write that as an e to the x squared plus 9, so plus 9 with respect to x. Whoops. So here we go, being as neat as I can. And let's have a think about this integral. Now to integrate such an integral, I'm going to apply substitution, and I'm going to use this substitution to help me. So I'm going to let u equal e to the x. So let me use this substitution in order to help me with this integral over here. So if I take u to be e to the x as my substitution, du over dx for when I differentiate. When I differentiate e to the x, I get e to the x. If I cross multiply here, du is going to be e to the x dx. And let's think about what we're going to do next. So what we can do is, in this instant, I have a 2e to the x dx term on top. So I can make this a 2e to the x dx. So if I go back to blue, currently I've got e to the x dx, but to get the term highlighted in orange, the 2e to the x dx, I can multiply both sides by 2. So by doing that, 2 times du is 2 du. That is equal to 2 times e to the x dx is 2 e to the x dx. So as you can see, I have a 2e to the x dx. So that is exactly what I have over here. So by the method of substitution, we can replace this whole term here by a 2 du. And with the method of substitution, I can replace the e to the x by u. But let's also think about these limits. So if I scroll down, let's work out the new limits. First of all, the new lower limit. So new lower limit. So for the new lower limits, so these limits are in terms of x. So the old lower limit is x is equal to half ln 3. So that is the old lower limit. And if I replace that in our substitution, we can get the new lower limit. So let's have a look. So we'll have u is equal to, here's our substitution, e to the power x, which is half ln 3. Now let's go one stage further. Using our law of logarithms, or the power law of logarithms, this half we can make it a power. So half ln 3 is the same as ln 3 to the power of half, according to the power law of logarithms. So I can write that as e to the ln 3 to the power half. And this brings me on to another fact, that e to the power ln a is a. So if e to the ln a is a, that would make e to the ln 3 to the half 3 to the half. So 3 to the half is the new lower limit, and 3 to the half we could express that as square root of 3. Okay, so that is the new lower limit. So in the same way, let's work out the new upper limit. So let me continue down here. So new upper limit. So for the new upper limit, the old upper limit is x is equal to ln 3. So remember, these are the values of x, these limits, as far as the limits are concerned. So it's x is ln 3. And like before, let's replace it in our substitution. So u is equal to e to the power. So here's our substitution. X being ln 3. And remember, e to the ln a is a. So that would make e to the ln 3, 3. So 3 being the new upper limit. Right, so let's move on to the substitution stage. So let's replace the data and let's substitute 2e to the x dx. So this is the 2e to the x dx term. Let's replace that by 2 du, and the e to the x term here, we'll replace that by u to give us a u squared plus 9 in the denominator. As for the limits, half ln 3, we'll replace that by root 3, and as for ln 3 on top, we'll replace that by 3. So moving on from there, so by substitution, so let's rewrite the integral. So as discussed, 2e to the x dx, that's going to be replaced by 2 du. So I'm going to keep the constant 2 outside and the du always goes inside. So let me check this term. So this term has been replaced. As for the e to the x, we'll replace that by u. So we'll have u squared plus 9. So we'll have 1 over, whoops, let me be as neat as I can. So 1 over u squared plus 9 in the denominator. And let's check that term. So we replace the e to the x term. With regard to the limits, half ln 3, we'll replace that by root 3. So here's our root 3, the new lower. And the ln 3, we're going to replace by 3. So let me write that 3 over here. That is our new upper limit. So we'll have 2 integration between the limits of root 3 and 3 of 1 over, and we have u squared. Now 9 is the same as 3 squared, so let me write that as 3 squared with respect to u. And I wrote it in this form because if I take my red pen, just to remind you, so there is a result to integrate 1 over x squared plus a squared with respect to x, and the result goes like this. It's 1 over a tan inverse x over a, okay, plus c for completeness. Now, if you're not aware of this result, I have created a video proving this result along with applications of this result, and I'll provide a link to that video in the description below. However, let's apply this result here. So keeping the 2 outside, so here's my 2 copied down. Applying this result, so we'll have 2 over, so 2 over. Our a terms, so a by comparison is 3, so it's 2 over 3. Tan inverse, so tan inverse. X is u, so we're integrating with respect to u, so x is u divided by the a term, a by comparison again is 3, so it's tan inverse u over 3. And we can apply that to our limits, so I'm keeping this 2 in other words inside. So let's apply our limits of root 3 and 3, so root 3 and 3, these are the new limits. So let me continue over here. Replacing the upper limit, which is 3, we're going to have 2 over 3 tan inverse, and the upper limit is 3, so I'll have 3 over 3 upon replacement of the new upper limit, minus in the middle, 2 over 3, so 2 over 3 tan inverse, and the lower limit is root 3, so upon replacement, root 3 over 3. Now I can cancel these 2 3's, so we're doing a tan inverse 1, okay? And if we go back to the question, we need to write it in terms of pi, so you must ensure that the calculator is in radian mode when performing the calculations. So let's ensure that our calculators are in radian mode. So we'll have 2 over 3 from here. Tan inverse 1, so that should give you a result of pi over 4. Minus the 2 over 3, okay? And tan inverse root 3 over 3, pi over 6. Now, moving on from there, so let me scroll down. So moving on from there, if we simplify, so let me simplify along the line. So I can cancel this 2 with the 4, so it goes twice. This 2 with the 6 goes 3 times, so we'll have a 1 over 6 pi from the first term here, minus 1 over 9 pi from the second term here, and that should give you a 1 over 18 pi, or indeed pi over 18. And as you can observe, this is exactly what we need to show as part of part C. So that completes part C. So not only that completes part C, that completes the question in its entirety. So I hope you enjoyed this video. If you did enjoy the video, be sure to like and subscribe, and I hope to see you again. Thank you.